Cunha review. First thing that we have here is the engineering design process. The first step of the engineering design process is to identify the problem. We do this by breaking down the problem into smaller pieces, and at this time we also list the criteria and constraints. So criteria, what exactly are we trying to get to do? What does our solution need to do? And what are some restrictions? The next step is to brainstorm. So what we do is we list all of our ideas. It doesn't matter if the idea seems dumb. You list all ideas, and you want to put all these ideas onto some sort of paper, make it nice and organized. The next step is to design. So we do this by drawing our 3 orthographic drawings. We want to label those. We want to put as many features and try and make it all to scale. And there's also the inclusion of an isometric drawing, which is the sort of 3D trippy looking one. That one, he doesn't usually make us do this one, but that one is also there and would be part of the design process. The next step is to build. This is where we would make our prototype, and we want to list out the steps on how it was built. The next step is to test and evaluate. So we want to put our prototype to the test and evaluate, and we want to analyze the data. We want to test and evaluate. We want to try out our prototype, and we want to analyze the results in order to then be able to do our Next, we want to test and evaluate. So we want to grab our prototype and we want to test it. We also want to write down exactly what happens. So we want to record all our data. That way we can analyze it and create an effective redesign. So our redesign is where we then do the same thing as our design over here, except that now that we've seen what didn't go well and what did go well, we want to apply that to try and create a solution to the problem presented in our test and evaluation. We would then repeat this cycle again and again until we finally come across what we believe to be our final solution. And we then share a solution in the form of, for us, the journal. The next topic is digital citizenship, and we have our 9 pillars here. The first one being digital access, which is the opportunity to give a contribution to the digital community. The next one is digital commerce. So this is the digital buying, selling, and trading of goods. So this is money type things like Amazon. Digital communication, digital exchange of information. So this could be email, texting. Digital literacy, the process of teaching and learning about technology and the use of technology. So this is where we're learning about how to use this technology. Then we have digital etiquette, which is the digital standards of conduct or procedure. So this is how you are going to be acting online. Next is digital law, the digital responsibility for actions and deeds. So the legal side. Then we have digital rights and responsibilities, and these are the freedoms and expectations extended to everyone in the digital community. So, what you're expected to do. Next, we have our digital health and wellness. This is the physical and psychological well-being in a digital technology world, so making sure you're taking care of yourself. And then the last point that we have is digital security, the digital precautions to guarantee safety online. Next topic is team building. So we have our 4 steps to team building here, or our 4 stages, as you could call them. The first one is forming. So this is the first stage of team development in which team members meet each other, form initial impressions, and begin to establish team norms. So this is the first time they're together. So we have our storming. That's right here on our little graph. And this is the second stage of development, characterized by conflict and disagreement, in which team members disagree over what the team should do and how it should do it. So this is when the first team conflict arises. Next up is norming. This is the third stage of team development in which team members begin to settle into their roles, group cohesion grows, and positive team norms develop. So we're starting to become more comfortable with our other team members. And then lastly, the highest stage, the highest level, is performing. This is the fourth and final stage of team development in which performance improves because the team has matured into an effective, fully functioning team. Next up are flowcharts. So we have here our different icons. So we have this rectangle, which is our process. Boxes, we got our diamond here, that is our decision making. Our parallelogram, that is our input/output. We have the circle, which is the connector. this rounded rectangle with a triangle thing on the back, which is our display, and finally our oval, which is our start/end. Here we have an example of a flowchart. So you start, he'll walk into class. Is the Cunha angry? Yes? Well then don't make any sudden movements, and good job, you've lived. But if the Cunha isn't angry, then what you're gonna do is just agree with everything he says and smile. Either way, you live. Next up are gears. What you are going to need to know is just the drive gear, driven gear, and gear ratio. So drive gear, this is our input gear. So this is the one that we're turning, the one that you're applying the power to. This is like what would be on the other side of the handle. And then you have your driven gear, which is your output. So this is the one being driven by the drive gear. So the one that the drive gear is turning. Then we have gear ratio, which is the ratio of output turns to input turns for a pair of gears. So we have the number of teeth on the driven gear, which would be right here. And then got our colon, and then number of teeth on the drive gear. So the driven gear is the one that goes first. Driven gear would be on top if this was like a formula, like slope. Then it'd be driven gear on top and drive gear on the bottom. Next up are our sensors. So the first sensor that we have here is the ultrasonic sensor. So the ultrasonic sensor uses reflected sound waves to measure distance between the sensor and any objects in its path. So it's always going to be transmitting these ultrasonic signals, these sound waves type things, that will bounce off, come back, and then it can use those to calculate the distance. We also have our touch sensors here. They can detect touch, usually human, and works as a switch. So they're just detecting our physical contact and reports back to the controller whether its contact area is being pushed in or not. Finally, you have your color sensors, and these are going to be detecting colors of a surface, and sometimes they can also detect the light level on the surface, and it'll usually have these in RGB form. Next up, we have artificial intelligence. What you're going to want to know is mainly this definition here. So, artificial intelligence is a machine that mimics the natural learning capabilities of humans. So this machine is able to operate on its own. It's going to learn based on whatever is being inputted into the machine. Okay, uses can include personal healthcare assistance, virtual shopping, possible ad targeting, so it'll see what you're doing on the internet, it can learn based on that and give you advertisements that make sense to show to you. Quicker banking, and also playing chess or video games. The next unit we have is the underwater robots unit. So we have the body, this is the frame, this connects everything together. Then we have the motors right here, these make it move. We have the control box on the other end of this long cable, which is it's the brains of the robot here. It's also what we use to put our inputs to control it. And then buoyancy, this is the balancing part of the robot. So how it acts in the water is based on the way that you buoyancy tested it and calibrated it. Next up is the Arduino unit. We have the breadboard here. This is a board for making an experimental model of an electric circuit. So we have our two power rails right here. These are connected in this way right here. They're going up and down. They don't connect across like this, because the ones over here, these are the ones that connect across. So all of these holes right here are all connected, like this, and like that. But they do not connect in columns like these do. So these right here connect in columns. These right here connect in rows. And these two are not the same thing. So there is one column right here, and then another column here. And each one of these are individual rows, and it's the same thing on the other side. Next up, we have the Arduino itself, and it's a microcontroller / circuit board. We have the IDE, which stands for Integrated Development Environment. It's an application that includes an editor, a sort of programmer's word processor, debugger, and compiler, among other tools. This is where you write your code. Then we have Sketch, and this would be your Arduino program that's been written in the Arduino IDE. So the IDE has two main functions called setup and loop. Void setup and void loop. Void setup is used to define the initial environment properties. It's only run one time. So if we look at our code here, it's where we would put what the pin modes are, what does this pin do, the output, input, that type of thing. Then we have our loop, and the void loop is going to be a programming construct that repeats a group of commands infinitely. It's a forever loop, essentially. So if we look right here, it's just going to be, this is the Blink program, by the way. It's just going to be looping this program right here, which turns the LED on, waits a second, then turns it off, and then down here, covered by the little menu, waits another second, and then repeats the process over and over until you unplug it. So void loop, the two parentheses and then the open curly bracket, is a part of a function definition, and a function definition is a statement that creates a new function specifying its name, parameters, and the statement it executes. So it's just basically saying that this is part of a function. Next up are our two slashes, two forward slashes. These indicate a single line comment, and multi-line comments are indicated by the slash and then an asterisk, and end with an asterisk and then a forward slash. We see those right here at the beginning. We have our forward slash, asterisk, then all of our text, and then to end the big comment is our next asterisk and forward slash. The unit of time in the Arduinos is milliseconds, so whenever we type in our delay, which adds a space before executing the next line of code, it's going to be counted in milliseconds. The time is always going to be in milliseconds. So 1,000 milliseconds is going to be equal to 1 second. So if you put 1 in there, it's not going to be 1 second. Putting delay and then having a 1 inside of that is not going to make 1 second. That would make 1 millisecond, which is 1/1000th of a second, and you don't want that. So 1,000 milliseconds is equal to 1 second. Last thing is that a range of numbers you can store in a variable is 0 to 255, or the other way around, negative 255 to 0. Final thing you need to know is just basic understanding of code. So we'll get into some more generic style code here in a second, but what we want to look at here is this Scratch programming with a C. And it's basically just a block style program. You'll just read exactly what it's telling you, and that's how you can figure out what's going to be happening. Just read it from top to bottom, see where everything's connected, and you should be able to figure out exactly what's happening. So on here, what it's trying to do is when you click the start button, it's going to put you at 0, 0. You're going to point in a direction. After waiting 1 second, it's then going to move forward 10 steps. And if it is on the edge, it's going to bounce. And it's then going to repeat this process again to move it 10 steps. And if it's on the edge, it'll bounce. And that'll just continue happening forever, or until you end the program. You can use this example right here for the more generic coding style type thing. So we have up here, it tells us that we're going to be turning on an LED for 1 second, then turning it off for 1 second. And the first thing we see here is our void setup, and it tells us that the built-in LED is going to be an output. We then go down to the loop, which says that it's going to be turning the LED pin, the LED built-in, on high, so turning it on for the delay of 1,000 milliseconds. So it's going to be on for 1,000 milliseconds, which is equal to 1 second. And it is then going to be on low or off for another 1,000 milliseconds, 1 second. It is then just going to be repeating this process, turning it on and off and on and off until the program, or until you close out of the program or tell it to stop. And that is it. Best of luck to you taking the final thing. Yeah.